Hello everyone, this is Sinead and I'll be showing the god of all suns. It's basically a star that is super massive. It's like, I don't know, man. It's like massive than you would even think about. It took me a long time to manage to do this, but wait, before I show the god of all suns, which looks like a green star, I'll show the other ones. This is C2020F3. I'm not sure where the heck that is, so I'm just gonna go to a new simulation. Here I'm gonna go to the there, C2020F3. I'm not sure if this was a solar system object or random object I found out, but this is 1.23 masses of Earth and 0.782 radiuses of Earth, so it makes it quite dense and quite high in surface gravity. I basically tried to make this habitable. Now I'm going to go to the next one. Earth, but almost a brown dwarf. Slightly bigger, but way more massive. There you go. This is Earth, that is 1.01 radius of Earth. That's like 6,400 kilometers, 6,435. And this is 9.90 masses of Jupiter. So that's like that over 1,000 times more massive. That's like around 3,000 times the mass of Earth. If we just compare it to Earth over here, 3,147. So that's quite heavy. So it has a surface gravity of 30.3 kilometers per second, and when I look over here, this is not possible, bro. You would instantly get crushed. So that's something the Universe Sandbox 2 needs to fix. Here's my other object, Earth. But this is 9.61 massive Jupiter, slightly less massive than the other one, but it's 2.72 radiuses of Jupiter. So when you just compare it to the biggest planet in our solar system right over here, it's way smaller. It has a density of 0.1 grams per cubic centimeter. That has surface gravity of quite heavy. It's quite heavy in surface gravity, but you could probably survive on there. But you would have very bad weight problems and stuff. Now moving on to the next one, Sun, but 1 quadrillion times it's a negative 1 quadrillion. That's why it says undefined surface temperature. 274 kilometers per second, and is 1,000 times the mass of Sun. So that's quite a lot. This will basically just take all the energy from a star, a planet I mean, but since it's so low in luminosity, this is just like ripping it apart. It's just vaporizing it. Now we have the Sun, but 1 quadrillion times the Sun, but 1 quadrillion times the luminosity. Same thing, same specs, but it is 1 quadrillion luminosity, or 1e plus 15. So this is going to be like this. Let's just say I put the Earth around it here, the Earth, but almost a brown dwarf. It's just getting destroyed. See, exactly, just destroyed it. Even though it was so dense. Like, sheesh. Now, here's the second last one. I mean, this one. Sun, but 200,000 solar masses. Since this is so close to becoming a black hole, reaching its Schwarzschild radius, if I just orbit something around it right away, it's going to turn into a black hole. But it's going to become smaller, 8.45 radiuses of Jupiter. So yeah, that's sad. I can barely do anything with it. I would just need to make this bigger, but not big enough till it vaporizes. So this is a 1000 solar masses sun, which is like the same as these, but it's just like as like the same luminosity as the sun, I believe. So now we have the god of all suns, the one you've been waiting for. Look at this. This is like almost 106 light years. Like, look how big that is. I change this into a green color, and it may look like, you could say this looks all normal until you see this. 10 times the mass of the Milky Way, and 39.5 light years in diameter. I mean radius. That means it is 79 light years in diameter. Solar radius, this much, which I'm too lazy to count right now. Then Jupiter radius, this much. Millimeters, 20, E20. It's quite far from being a galaxy radius, but yeah. So it's 10 times the mass of the galaxy. It looks kind of normal from here since you're not seeing how big it is. But let's just say we compare a black hole to it. Black hole 10 million solar masses. I just put it right over here. And then I'll just speed up time. And bruh, look at this. This man is not doing nothing. That's like a trillion times more massive than the sun, our sun. And this is only 10 million. Like, look, it's doing nothing. It's like a little baby or something over here. So somehow it won, I don't know how, but this, I don't know. But yeah, as you can see, it's quite a massive thing. Okay, I'll go back to our god of all suns, and we can do some comparisons with it. Let's just try out Stephenson 2-18, which is the largest star ever discovered, basically. Just gonna put this right over here. There you go. It's basically nothing. So as you can see, nothing's gonna really even happen. I think this star is like too big and has very little density to even like affect the star in any way. But really, when you just collide this into that, I don't think nothing's gonna happen. Look at that. It only got a little mark over here. So that's quite massive. Here's some more tests I can try out. Solar system, right over here, right? Quite large. Our sun is over here, and then the orbit of Sedna over here is super big. And I don't know what trail is that from here, but it's quite big. It's like the whole solar system is like 1 to 2 light years in diameter or something like that because of the Oort cloud. But this is only like, I don't know, 30 to 50 yet, like around 100 astronomical units, I guess, or 200, 300, 400, 500, 700 maybe. Now this is the god of all suns. Look at this abomination, bruh. Like this is just like a grain of rice or something. Bruh, they're like even making it oversized actually. I don't know where are these from, but yeah, they're quite large. So everything is moving towards it at like such fast speeds. But yeah, as you can see, it's like less than even a grain of rice. You could call it some like 110 micrometers if you were like a human and this was like that small thingy. This would be like, I don't know, 110 micrometers or something like that. So that's quite a big difference. And now, as you can see, it's just going towards the sun, the god of all suns. Let's increase this. 100 years a second. There you go. Nothing happened except this explosion right over here. Yeah, look at this, bro. So this is hella massive. And then there are probably more things we could just try out. We can try making a solar system around this thingy. So we will put the god of all suns over here. Put a habitable zone. Let's enable the habitable zone around it. Right over here. There you go. This is the whole habitable zone. So that's like reaches so many light years in diameter, or something like that. Let's put Mercury should be around and Venus should be around, I don't know, here. Then Earth would be around here. I don't know, man. I'm just, there's this problem with the habitable zone. It's like an update, but I don't completely understand it, so I'm just gonna leave with these. And now they're just starting to orbit. Like, sheesh. This is already minus 270 degrees. With Mercury over here also minus 270. This is minus 263 because of its intense atmosphere. As you can see, this is like 0.5 million years per second, just because of how big this thing is. Let's just put this. Let's just put this right in. It's nothing happening. It's not even affecting. So I think we need to enable more luminosity of the god of suns. Because even though it has such a high luminosity, it's not going to be hot enough. So for example, I'm just going to put Earth right over here. I'm going to put it super close. There you go. It's barely going to make any difference. Has a eerie green color, and it has an orbital period of still 1,030 years. So that's quite a lot. It's even decreasing. I don't even know how much it's gonna go to. And the hottest temperature is minus 104. Look at that, 20%. I don't think there's even any life likelihood. So what I can try doing is I can get it closer to the star. But I can barely even zoom out. After this, there's going to be one more experiment I'm going to try. And I'm going to show you. It doesn't work. So I'm going to try this one more time. And then I'm going to show an experiment with the god of all suns. Over here. And then we're going to add our Earth. Wait, I'm just going to add Earth. And, nah, I'm not going to add this. I'm going to add the smaller, more dense Earth. Over here. Earth but almost a brown dwarf. Now, I'm gonna increase this luminosity by a lot, because this is definitely not enough. Okay, never mind. Then maybe that was too much. You know what, let's just leave that. And we're gonna move on to the Milky Way. Since this is 10 Milkies, it's gonna make a huge difference. Quite big. I don't know what's wrong with the code over here, but yeah. This is our Milky Way, 0.999. I'm just gonna fix this and make it 1. Milky Way, also make this 1. Milky Way. I can even see a difference, but yeah, this should be that. 1 Milky Way. And then I'm gonna add the God of all suns. And then I'm gonna add this over here. There you go. So even the black hole in the middle, Sagittarius A, is basically all done for. It's only 4 million times the mass, so nothing's really gonna even happen. We're gonna increase the speed by a lot. Look at what's happening. Seems like this is being the orbital thing around, but since this thingy over here is just like having that gravitational pull, it's just going to like pull the God of all suns, but barely even moving, as like over here. Only 540 kilometers per second. I can try another thing. I think I still have 2 more things to do. God of all suns. No, actually, I'm gonna add the God of all suns, and then I'm gonna do Milky Way galaxy. It's gonna be around orbit. As you can see, it's now in orbit. 3,263 kilometers per second. It doesn't matter. I'm just selecting the different things. But we have the God of all suns here, and then I'm just gonna speed up the time by quite a lot. It's still gonna like rip apart the whole thing, but I'm just doing it because why not? Look at that. Man, this thing is probably moving like quite fast, 0.0351 C, which is basically light speed. But it's messing the whole thing up. So yeah, this was quite fun though. My video is probably gonna be quite boring because I don't know. I gotta improve in making these Universe Sandbox 2 videos, since it's already like 19 minutes long from what I can see. So I don't think I'm gonna get many viewers on this. But this is the last thing I'm gonna do. I'm just gonna add black hole 1 solar mass right over here. I'm gonna have it collide into it. Increase the speed. Let's see what happens. So it's starting to approach the surface, and we just need to. Oh damn! Somehow it won, and it's now 10 mass the Milky Way. So that's quite sad, honestly. Well, I guess that's it for today's video. Today's quite boring video, I guess. I just gotta improve my video making skills on Sandbox 2, even if I don't edit on this. But until the next time, I'll see you guys later. I may make another more massive star, so it can compete on maybe IC1101 and make it the true god of all suns. Well, anyways, I'll see you guys next time. Goodbye.